Hey guys, welcome to lesson 8 of how to build iPhone apps with no programming experience. And in this lesson, we're going to build upon the last and continue learning a couple more concepts of the Swift programming language. We're going to look at subclassing and UIKit. So let's start with the first, subclassing. In the last lesson, we learned about classes and how you can create a class to describe a component in your app. We also said that you can create multiple objects from one class, and that's really convenient because let's say that we have two identical components in our app. We can write a single class and create two objects from it to represent the two identical components. Well, consider this scenario. What if you need two components in your app and they're not identical, but they're very similar, let's say 90% similar in their behavior and what we want them to do? Well, you could write two separate classes, one to represent each of those components where 90% of the code in those classes are the same, but that's a waste of effort. And furthermore, it's generally a bad programming practice to have duplicate code everywhere because it makes code maintenance and debugging harder than it needs to be. And this is where subclassing comes in. It allows us to handle a scenario like this without having to duplicate 90% of that code. In other object-oriented programming languages, there's a concept called inheritance. And in Objective-C and Swift, it's known as subclassing. So a subclass is a class that inherits the properties and methods of another class. So going back to our scenario with the two similar components, we can write one class to describe the behavior of the first component. Then we can write a second class and declare it as a subclass of the initial class that we wrote. When we do this, the second class has all of the properties and the methods that we declared in the first class, and you don't have to rewrite or redeclare all of those properties and methods. Instead, we can just write code to represent the difference in the second class. In this relationship, this is the subclass, and this is the superclass, although sometimes I refer to the superclass as the parent class. Now let's go back to our playground and see what a subclass looks like. So I'm going to start a new playground. I've got Xcode open here. We call it subclass playground and just save it on the desktop. Okay, so in the last lesson we had a class called person. So I'm just going to declare a person class again. So if you practice it a couple of times, you might start to realize that even without trying to memorize exactly how to declare a class, you may remember how to do it. So following along and trying it out on your own computer really goes a long way to help you remember things without having to memorize things. So if you remember, we need an init method. And this time, okay, let me declare a property here. And we'll give it an initial value of initial name. Okay, and next I'm going to declare a method called walk. And if you remember how to declare methods, you use the func keyword followed by the method name, and then a set of round brackets, and then a set of curly brackets. Inside here, when this method is called, I'm just going to print line, I'm walking. Okay, so let's test that out. I'm going to declare a variable a and assign a new person object to it. And then I'm going to set this object's name property to Alice. And finally, let's call the walk method and just see it print line here. Okay, now we're going to demonstrate subclassing. So I'm going to create another class which will subclass person. And I'm going to call this one superhuman. And the way that you declare, specify a subclass is you use colon and then you put the name of the superclass. Like that. So just like that, I've declared a class and it inherits all of the properties and methods of the person class. I don't even need to specify an init method or initializer. Watch this. So I can go var b equals superhuman to create a new superhuman object and assign it to the variable b. And now I can go b dot name, and you can see that it registers it as initial name, and I can go say b dot walk, and you can see now that it printed it 2 times. So just like that, even though I don't have any of that stuff specified in here, because superhuman is a subclass of person, it has all of person's methods and properties. So this can be really handy. Next, let's give superhuman some sort of additional functionality, because otherwise we wouldn't need to create a subclass, right? So in superhuman, I'm going to add an additional method called fly. And inside the fly method, I'm going to print line, I'm flying. Okay, now I can go b dot fly is available to me. And now you can see that that method is called and I'm flying is printed out. Let's also add an additional property for good measure. So up here, I can add alter ego name string. Can just set that to Clark as an initial value. I can see that when I go b dot, you can see that the 2 properties are available. Alter ego name and fly are methods and properties inside the superhuman class, and name and walk are from the person class. Now if I went a dot, you can see it only has name and walk because a is a person object. In this relationship, superhuman is the subclass and person is the superclass, ironically. Okay, let's consider another scenario. In this case, we have a subclass, superhuman, that provides additional functionality. But what if I wanted my subclass instead to override or provide a different functionality than the parent class? For example, what if I wanted, when I call b.walk, for the walk method to do something different than the walk method that was coded in the person class? Well, you can actually do that. So the way to do that is you can go override and then redeclare the exact same method as in the parent class. So there's walk, set of brackets, and then set of curly brackets. And this override keyword now, when you call walk method on superhuman, instead of executing this code in its parent class, it executes this code. It's superhuman's implementation of the walk method. So in this one, I'm going to say print line, I'm walking really fast. So let me erase these and demonstrate. So now when I go b.walk, you can see that this was triggered. I'm walking really fast. Now if I didn't have this, this method call would execute its parent class's functionality. There's also a mechanism where you can do both. So in this overridden method, you can say, print line, I'm walking really fast. But if you wanted to run the parent class's implementation, you can go super.walk. And super stands for the parent class. So I can do that. So now when you say b.walk, what happens is that it calls this override function, this overridden walk method, and it executes this line, and then it calls the parent class's walk method and executes this code in here. So there's some flexibility there and some powerful tools at your disposal. While we're on the topic of overriding, I want to mention one thing is that if you want to provide a custom initializer method for Superhuman, you would also need to override it, and you would do it something like this. Override init. And here you could provide your own custom initialization for Superhuman. However, if you try to access your parent class's properties or methods in this initializer method, you're going to get an error. So let's say super.name equals superduper. And you're going to get an error here that says self used before super.init call. And it's basically complaining that you haven't called the parent's initializer method yet, so you can't use any of its properties or methods. So all you have to do is actually just call super.init before you use any of the parent class's properties or methods. The reason is because the parent's initializer method may initialize some values in the properties, or it may set up some of the methods for use. So before you use any of it, you actually have to give the parent class a chance to initialize or set up anything it needs to set up. Now you actually know quite a bit about the Swift programming language and how it's structured, and you know about the tools available to us to create these classes and describe our components in the apps. Well, you'll be happy to know that Apple actually provides us with a whole slew of classes that are available to us to use to build our apps. It makes building apps a lot easier because it lays out a lot of the groundwork that we need already. That set of classes that Apple provides for us to lay out the groundwork for our app is called UIKit. And UI stands for user interface. So let's take a look at the documentation for it. So if you go to Google and type in UIKit, you'll get a whole bunch of results, but it's not this one. So don't be fooled by that. Scroll down until you see something from developer.apple.com, this UIKit framework reference. And the page should look like this. So in your own time, if you read this little bit of introduction and what sort of functions and features that UIKit provides, you'll see that I kind of understated it when I said that Apple provided a set of classes for us to use. It's actually quite extensive and covers a lot of different functionality. But we're going to scroll down until we reach this heading called classes. Along the left-hand side are all of the classes that are in UIKit, and on the right-hand side are the descriptions for each of those classes. However, you'll notice that they're not all spaced evenly. You'll notice that NSObject is here as a root node, and then underneath it are a couple more, and underneath NSParagraphStyle is NSMutableParagraphStyle. Well, actually, NSMutableParagraphStyle is a subclass of NSParagraphStyle class, which is a subclass of NSObject. NSObject is actually at the very, very top. It's the root class for most, and it says Objective-C here, but you can substitute that with Swift because Swift uses UIKit as well. So NSObject is the root class of most Swift class hierarchies. All of these other classes are subclasses of NSObject, directly or indirectly, because sometimes it goes several layers deep. If you scroll through this list of classes yourself, you'll see how long it actually is. There's a huge collection of classes here for us to use. So what usually happens is that before we create our custom class, if there's something similar already in UIKit, what we want to do is we want to subclass the UIKit class, and then either using overriding or additional methods and properties, code up our unique behavior. But we can use, if we can, use a UIKit as a parent class or a superclass, then we can inherit a lot of functionality without coding it ourselves. And then in the next lesson, I'll point out which ones and what they do. We're going to be referring to this page a lot, so make sure you bookmark it or have some way of getting back here. It's also very useful because you can click into each of these classes and you can get some documentation on how to use this specific class. And they have Swift or Objective-C, or you can view both.